Good morning, afternoon, or evening, cats and dogs. Today's video will cover the Lesson 5.4 guided notes on the distributive property, questions 1 through 20. Again, as a reminder, make sure you have these videos out and next to you. Make sure you have a writing utensil and a calculator as well, because you want to make sure you copy down these guided notes exactly as they are in the video and on the screen that you're going to see, and make sure that you are actively practicing plugging some of these things into your calculator as well. The distributive property is a really foundational concept, something that you're going to use pretty much from here all the way through your next several years of math. It's something that I use really frequently on a daily basis if I'm trying to do some mental calculations. My son constantly, my 5-year-old, is trying to quiz me about math facts, some of them quite difficult at times. For example, he asked me what 64 times 64 was the other day. And I sort of used a combination of the distributive property along with FOIL, something you'll learn. It's like the double distributive property that you'll learn if you take Algebra 2. So I was able to figure that out mentally, again, using some of the skills from this lesson. So you have to have a pretty good foundation in this to be successful in some other things. We're just going to be going through the basic number questions with some variables, and then my hope is for us to do some of the word problems on this lesson together, and of course review this concept together as well, since it is so foundational. So let's show you how we can represent or show the distributive property visually. So I have this figure here on the left, and it says to find the total area. I have a rectangle, a larger rectangle on the left, and then a smaller rectangle on the right. So the area of the rectangle on the left is 2 times 4. If you recall, the area of a rectangle is length times width, or base times height. So I know that I'm going to take 2 times 4 for this guy. And then to find the area of the rectangle on the right, I'm going to do 2 times 1. So you can see that represented in the yellow highlighted area once I highlight it. Down below, where we have 2 times 4 plus 2 times 1, since we're trying to find the total area. Let's actually calculate that. 2 times 4 is 8. 2 times 1 is 2. Add those together to get a total area of 10. 10 units squared, whatever that may be, feet squared, inches squared, meters squared. The figure on the right is the exact same figure, except the two, since they actually happen to have the same height, or width, depending on which measurement you're looking at, or length, I put the two rectangles together to form one big rectangle. So you can also multiply base times height by taking 2 times the sum of 4 and 1. And 4 plus 1 is 5, and 2 times 5 is also 10. So the reason why we look at these two different ways is to show you that if I have 2 times in parentheses 4 plus 1, that is the same as 2 times 4 plus 2 times 1. The word distribute means like to hand out, to give out. Everyone gets one. So if I'm distributing papers to the class, everyone is going to get a paper. So the distributive property basically says that this number that's outside the parentheses has to be multiplied by each term or each element inside the parentheses, like here, 2 times 4 plus 2 times 1. So we're going to do some practice starting just with numbers here in a moment. Oh, forgot to cover this one up. And the reason why we're just doing numbers here is because we're eventually going to throw in variables, but variables do have a tendency to confuse people, which is understandable. It's weird to have letters in math when we normally work with numbers. So we start just with numbers, and I do think that sometimes students are like, well, why do I have to do this? This is silly. Why do I need to do it this way when I could do it easier another way? That's understandable, but you won't have those shortcuts when we throw in variables in a few moments. So that's why I'm showing you a specific way here, and I do ask that you write it down this way for now, because for the most part, your questions from here on out are going to involve variables, and you won't have any shortcuts. Now, the box up here just does show you, using variables, what the distributive property looks like. Basically, you take whatever number or variable or term is outside the parentheses, and you multiply it by each element inside the parentheses. If you have an addition sign in the parentheses, you carry that over. If you have a subtraction sign in the parentheses, you carry that over. I do stress this over here, where the variables behind the parentheses, we will actually rewrite it with the variable in front of the parentheses instead. We're allowed to do that, and we'll talk about why in a few moments. We just need to make sure that we multiply the first term on the left in the parentheses by the number that's outside, followed by the second number from the left by the number that's outside. So it is kind of important that it's in a specific order, not really for addition, but for subtraction, since subtraction is not commutative. So in the exercises, the first, I believe it's 6 questions, it says to use the distributive property to write each expression as an equivalent expression, then evaluate it. Now, I am well aware that in question number 1, you could do 6 plus 4 to get 10 and do 10 times 2 and get 20, but it's not asking us to do that. It's asking us to use the distributive property, meaning I need to distribute the 2 that's outside the parentheses by each thing that's inside the parentheses. So I've got to make sure to take 2 times 4. I'm just going to put some little arrows in here. Sorry, 2 times 6, and then add on 2 times 4. So I'm going to take 2 times 6 plus 2 times 4. So I start by writing that because it does ask us to use the distributive property to rewrite the expression as an equivalent expression. Now evaluate. 2 times 6 is 12, 2 times 4 is 8, and 12 plus 8 is 20. Again, I know that a lot of you are thinking, well, I could have done 6 plus 4, got 10, and done 10 times 2 to get 20, and that would have been a whole lot quicker. And I agree with you, but it's asking us to use the distributive property. So let's practice it right now with just numbers, and eventually you'll throw in some variables where you won't have that shortcut. So in numbers 2 and 3, the number is behind the parentheses. I do suggest you rewrite it with the number in front of the parentheses and then distribute. So in problem number 2, I'm going to distribute the 5 into the parentheses. I'm going to take 5 times 8, and I'm going to take 5 times 3. So I'm going to write it as 5 times 8 plus 5 times 3. 5 times 8 is 40, 5 times 3 is 15, and 40 plus 15 is 55. The answer itself is less important than the step I'm going to highlight in green. This step shows that you know how to use the distributive property. All right, in number 3, the very first thing I'm going to do is I'm going to rewrite it with the 4 in front of the parentheses. That just makes things a lot easier. I'm not saying you have to do that, but if you distribute the 4 from behind the parentheses, you have to do 4 times 6 first, and then do 4 times 3, because you're going to be subtracting, and order matters when we subtract. So I'm going to write this as 4 times 6 minus 4 times 3. 4 times 6 is 24. 4 times 3 is 12. And 24 minus 12 is 12. By the way, you can use your calculators here, so I would certainly encourage you, if you don't know basic multiplication facts, which you should, use your calculator. If you want to double check your work, use your calculator. We're going to mix in some negatives here in a moment, so you'll definitely want to have your calculator handy for those. In number 4, we're going to distribute the negative 6 into the parentheses. So we take negative 6 times 12, and negative 6 times 4. So I'm going to have negative 6 times 12 minus, and pay attention to the little details here, negative 6 times 4. Now, this is where you really want to use your calculators, just to double check your work. You should know what negative 6 times 12 is, but using your calculator to double check is a great idea. Negative 6 times 12 is negative 72 minus, and then negative 6 times 4 is negative 24. So you have negative 72 minus negative 24. I did rewrite it as negative 72 plus 24, but you could skip that step and then just do negative 72 minus negative 24 in your calculator. You will get negative 48. And again, you can skip. I'll go ahead and highlight this in blue. You could skip this step to get negative 48. Now, the last question on this page says, why in numbers 2 and 3 can you simply move the number in front of parentheses? What do we know about multiplication? If you're thinking we can multiply in any order, you're correct. So multiplication is commutative, like we talked about in lesson 5.3. So you can move the number from behind the parentheses to be in front of the parentheses, again, because we can multiply in any order. We'll pause there for a moment. Again, feel free to pause the video if it's not enough time for you to copy any of this down. All right, let's go ahead and take a look at the last two questions using just numbers on the back of this next page. We mixed in some decimals and fractions, and we are allowed to use our calculators to do problems like this. So if we have 2.6 and then in parentheses 7 plus 5, we are going to do 2.6 times 7 plus 2.6 times 5. So I'm going to write it just like this. Using my calculator, 2.6 times 7 is 18.2, 2.6 times 5 is 13. When I combine them together, I'm going to get 31.2. And again, this final answer is less important than the green highlighted step, which is this, showing we can use the distributive property. Number 6 does involve fractions, so hopefully you've already viewed the very short video on how to use your fraction key on your calculator. I know there may still be some issues with using the fraction key in your calculator, so it's something we can certainly talk through and give you some help. I also hope to address this in class with you a little bit as well, so you have a chance to kind of see how to use the fraction key in your calculator to do calculations like this. So I made a short video, but it's also something that we may introduce in class as well. So I want to distribute this 2/3 into the parentheses. So we're going to take 2/3 times 15, whoa, and multiply 2/3 by 9. So I'm going to write it just like this, 2/3 times 15 minus 2/3 times 9. 2/3 times 15, again, using your calculator, using that fraction key. Hopefully you were there in class the day we talked about how to do that. If not, again, I made a very short video on how to use the fraction key on your calculator. And if you're still having issues, check in with me. I really want to make sure you're good at using your calculator to do some of these things, because it can really help you be successful. 2/3 times 15 is 10, and 2/3 times 9 is 6. By the way, I just do 15 divided by 3 to get 5, and 5 times 2 to get 10. I do 9 divided by 3 to get 3, 3 times 2 to get 6. It works out well if the number you're multiplying by is a multiple of your denominator. And of course, 10 minus 6 is 4. The same way, if I took 15 minus 9 and got 6, 2/3 of 6 is 4. All right, so for the second half of the video, we are going to mix in variables, certainly important for us to be able to work with because you're essentially taking a pre-algebra class. So let's talk a little bit about what like terms are. Like terms are terms that contain the same variable or variables with the same exponent or exponents on those variables. Expressions that do not contain any like terms cannot be simplified using addition and subtraction. You are allowed to multiply terms that are not like terms, though, which we've kind of already done. So for example, if I have negative 4a times 2b, I can take negative 4 times 2 and get negative 8 and just tack on the ab. They're not like terms. Negative 4a has a different variable than 2b, but I'm allowed to multiply them. But if I said, what's negative 4a plus 2b, you can't do anything with that because they're not like terms. So there's a couple of examples here. For example, 4x plus 2 cannot be simplified because 4x and 2 are not like terms. So if you want to write an answer, 4x plus 2 is as far as you can go. Don't you dare write 6x. But in example 2, we have 4x plus 2x. That can be simplified to 6x because 4x and 2x are like terms. They each contain an x. If I have 4x's and I add on 2x's, I can combine them to get 6x's. That's really, 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 really important as we go to finish up these examples because I will have students give me answers that are not correct. And I can guarantee you that if it's a multiple choice question with something like number 7, there will be an answer choice where you've combined things that aren't like terms. So be really careful. So in numbers 7 through 20, it asks us to use the distributive property to write each expression as an equivalent algebraic expression. So this one's going to be very similar to the ones with the numbers, but we're not quite going to be able to go as far. So you're not just going to get a number answer here. You're going to get an algebraic expression. So I'm going to distribute the 3 into the parentheses. I'm going to take 3 times x, and I'm going to take 3 times 1. So I'm going to write this as 3 times x plus 3 times 1. 3 times x is 3x. 3 times 1 is 3. I cannot go any further than that. 3x and 3 are not like terms. Now, I hope that you get to the point where you can skip the step I'm going to highlight in yellow, where you don't even need to show this, and you can just look at this expression and say, oh, that's 3x plus 3. You will get there. It might take some time. In number 8, I'm going to rewrite this guy with the 5 in front of the parentheses like this, and then I'm going to distribute the 5 into the parentheses. I'm going to take 5 times y plus 5 times 4. So it's going to look like this. Let me slide this up a little bit. So we're going to have 5 times y plus 5 times 4. Final answer, 5y plus 20. All right, number 9, I'm going to distribute the 4/5 into the parentheses. So 4/5 times a and 4/5 times 5. It's going to look like this. 4/5 times a is just 4/5 a, and 4/5 times 5 is 4. All right, last one from this section. I'm going to move the 3 in front of the parentheses, and then I'm going to distribute that 3 into the parentheses. So take 3 times b and 3 times 6. You don't need to write those arrows, but if it helps you, feel free to do that. 3 times b is 3b. 3 times 6 is 18. We get 3b plus 18. All right, moving right along to the next section. Again, feel free to pause the video at any point if you feel like you need to because you don't have enough time to write it down. I know I'm moving through it quick, but that's because I have all the work written down here. In number 11, I need to distribute the 2 into the parentheses. So I'm going to take 2 times x. Let's see if I can squeeze that in there and multiply the 2 by 3. So you have 2 times x minus 2 times 3. Final answer, 2x minus 6. Done. All right, number 12. Move the 7 in front of the parentheses and then distribute it. So we're going to take 7 times r and 7 times 3. So 7 times r is 7r. 7 times 3 is 21. So final solution, 7r minus 21. Number 13, go ahead and distribute that negative 3 into the parentheses. Again, anytime we have some negatives, you might want to grab those calculators and just double check your work. Negative 3 times x and negative 3 times 4 is going to get us negative 3x plus negative 12 from negative 3 times 4. Now, I wrote another answer here. You don't need to list both of these, but I just want to show you that these two are equivalent. This one is representing the same expression using subtraction, and if I add the opposite, I get this guy. So let's say this is a multiple choice question. Maybe this answer is there, but this one isn't. They're equivalent. So being able to recognize equivalent expressions is something that's really important for us. All right, number 14, I'm going to have a hard time putting my arrows in there because the record button's right up here, so I don't want to stop this recording. So I'm not going to put the arrows for this one. We're going to take negative 2 times y minus negative 2 times 1. Negative 2 times y is negative 2y. Negative 2 times 1 is negative 2. So I have negative 2y minus negative 2, which is an acceptable answer, but it's best if we can write this as negative 2y plus 2 by adding the opposite. That does make things look a little nicer. We typically won't leave subtracting a negative in there. Again, the main point here is distributing that number that's outside the parentheses by each of the numbers inside the parentheses. Goodness, I hope you can't hear my stomach growling. Finished a 19-mile run this morning and now I'm recording this and haven't eaten anything yet, so my stomach's growling. Oh boy. All right, we've got a few more to take a look at before I can grab a snack here. So we've got negative 2/3 to distribute into the parentheses. And again, we've either discussed in class how to use your calculator to do fractions, or again, there is a short video you can watch as well to help you with multiplying with fractions on your calculator. So distribute the negative 2/3 into the parentheses, negative 2/3 times x, negative 2/3 times 12. And again, it's really important to be precise, not dropping off any of those negatives. Negative 2/3 times x is negative 2/3 x. In our calculators, negative 2/3 times 12 is negative 8. Again, I would just do 12 divided by 3 to get 4. 4 times 2 is 8. But we don't like to leave subtracting a negative, so I would finish by writing this as negative 2/3 x plus 8. This, I'm going to highlight it in green just to point it out, this would be acceptable for an answer, but it probably won't show up if it's a multiple choice question. It'll probably be this answer right here that I'm circling. Number 16, I'm going to move that negative in front of the parentheses. It looks really weird. We have to put the negative in parentheses there, otherwise it looks like we're subtracting 5. So I dropped the parentheses off and I moved it in front. Now let's distribute that negative 5 into the parentheses. So we're going to do negative 5 times z minus negative 5 times 2, just like this. That'll get us negative 5z minus negative 10. And I did rewrite it as an addition problem, so negative 5z plus 10. All right, we're almost there. Number 17, let's distribute that 1/4 into the parentheses. We're going to take 1/4 times 3x and 1/4 times 2. Just like this. So we've got 1/4 times 3x plus 1/4 times 2. You can't type the x into your calculator, and I know I have kids who are like, well, I see a variable here on my calculator. Can I just type that in? That's not meant to do algebraic expressions like this. Just type in 1/4 times 3, which is 3/4. Hopefully that gives you that answer. It might give you the decimal of 0.75. We've got 3/4 x plus, and then 1/4 times 2 is 1/2. And your calculator should automatically simplify it for you, which is really awesome as well. All right, we're almost there. So let's distribute the negative 6 into the parentheses for the next one. Negative 6 times 2x minus negative 6 times 1. So it's going to look like this. Negative 6 times 2x, again, you can't type the x in, just type in negative 6 times 2 is negative 12x, minus negative 6 times 1 is negative 6. I would suggest rewriting that as negative 12x plus 6. All right, last two, and then I have some independent practice for you to try. Next week, we'll also see some of these in class. I think it's important to review this since it's such a foundational concept. Let's go ahead and distribute here. We've got some more challenging questions. These are a little bit higher level. So I'm going to distribute the 4 into the parentheses here. We've got two different variables. So I've got 4 times 3x plus 4 times 2y. 4 times 3x is 12x. And 4 times 2y is 8y. Just a reminder that we are allowed to multiply things that aren't like terms. We just can't add them. And if you wonder why, it's because 4 times 3x is really 3x plus 3x plus 3x plus 3x. It's like adding 3x 4 times, which means we're adding like terms. We're able to do that. All right, last one. Let's distribute the negative 5a into the parentheses. So we're going to take negative 5 times 4b, and we're going to take negative 5a times 3c. So negative 5a times 4b, oops, let me write that there. Negative 5a times 4b, just take negative 5 times 4 is negative 20. Tack on the ab. So I get negative 20 ab. For negative 5a times 3c, take negative 5 times 3 to get negative 15. Tack on the ac. So final solution, negative 20ab plus negative 15ac. And we cannot combine those because this has an ab, this has an ac. It's not the exact same thing. Over here, I had an x and then I had a y. Again, not the same variable, so I can't combine them. But I guarantee you, if a question like number 19 is on a quiz or a test, one of your answer choices is probably going to say 20xy. So please be careful with that. All right, I do have some independent practice problems for you to try. So once they're up here, I want you to pause the video, give these 6 a try, and when you're ready, start the video again. All right, I hope we did pretty well here. I didn't show all the in-between steps, but in number 1, I'm going to take 5 times x plus 5 times 9. That should get you 5x plus 45. 5 times x is 5x, 5 times 9 is 45. In number 2, distribute the negative 3 into the parentheses. We're going to take negative 3 times y and negative 3 times 7. So you get negative 3y plus negative 21. You can also choose to write it as negative 3y minus 21 as well. Number 3, distribute the 4 into the parentheses. 4 times z minus 4 times 9 is 4z minus 36. Number 4, distribute the negative 2 into the parentheses. Negative 2 times a is negative 2a. Negative 2 times 4 is negative 8. So you've got negative 2a minus negative 8, which you can rewrite as negative 2a plus 8. Number 5, distribute the 6 into the parentheses. 6 times 2b is 12b. 6 times 4 is 24. Last one, distribute the 7. 7 times 3c is 21c minus 7 times 2, which is 14.
All right, so let's go ahead and continue with the lesson 5.4 guided notes. We're going to see some word problems related to the distributive property. So our goal is to use the distributive property in those examples. So number 21 says, a one-day pass to an amusement park costs $40.95. A round-trip bus ticket to the park costs $5. Part A, write two equivalent expressions to find the total cost of a one-day pass and a bus ticket for 15 students. So there's many different ways that we could represent this, and our goal is essentially to use the distributive property in our two equivalent expressions, which means equal expressions. So the first expression that I wrote was this, 15, since we have a total of 15 students who are going on the field trip. So I'm going to highlight this 15 here. And then in parentheses, I put the $40.95. That's for the one-day pass to the amusement park, and the $5. And I added those together because we need to add $40.95 and $5 to get the total cost for each student, and then multiply it by the number of students who are attending this field trip or trip that we're taking, which is 15 students. So this is one way to represent it. Now, sometimes I have students who will add $40.95 and $5 together and get $45.95 times 15. Technically, that's the same. It's an equivalent expression, and that's fine as well. But I like to write it with the number of students outside the parentheses or number of people outside the parentheses, and then finding the total cost inside the parentheses by adding the different items that people are going to be purchasing. A second way to write this is like this, where we have 15 times $40.95. That's as if I'm distributing the 15 to the $40.95, plus 15 times 5, again, distributing that 15 to the 5. Because each of the 15 students is going to get that one-day pass to the amusement park for $40.95. That's this first part. So I'm going to highlight that in blue. That represents the total cost for the amusement park for the 15 students. And then the second part represents the total cost for the bus tickets for the 15 students. And then, of course, we add them together to get the total cost. Now, as is pretty traditional for these problems, Part B is going to ask us to find the total cost. And we're allowed to use calculators for this. So you'll just kind of see I picked one of the expressions. I chose the second one. I took 15 times $40.95 and got $614.25. So that's really the cost for the amusement park tickets for the 15 students. And then I did 15 times 5 to get 75. Remember, we still have to follow order of operations. And even though we're using calculators, I'm still asking that you show some work. Like, what are you plugging into your calculator to get your solution? I don't have direct access to your calculators as you're plugging things in. So you still need to show that work so I know what you're plugging into the calculator. And if you have all the work right and the answer is wrong, it's probably just that you plugged it into the calculator wrong. So I still want to see that work. When you plug this in, we should get a total cost of $689.25. Number 22 is going to be really similar, so let's take a look at this. A canoe and camping class costs $80.75 per person, including the cost for a canoe and tent rental. The cost of food is an additional $39.50 per person. Part A asks us to write two equivalent expressions to find the total cost of one trip for a family of 4. So in our last question, we had 15 students. In this one, we've got a family of 4. We have two different things that they're purchasing. The canoe and camping class with the canoe and tent rental, and that's $80.75 per person. And they also have the cost of food, which is $39.50 per person. So the two expressions I wrote were these. 4 outside the parentheses for the family of 4. And then in parentheses, the total cost, the $80.75 plus the $39.50 that it's going to cost for each person for those two different things. The second one, I used the distributive property, and I wrote it as 4 times $80.75. What that'll do is give us the total cost for the entire family for the canoe and camping class. And then 4 times $39.50, which gets us the total cost for food for the family of 4. In part B, we find the total cost. So again, just choose one of the expressions. It doesn't matter which one you choose. Some may choose the first one since you just have to add and then multiply. Here I had to do two products, two multiplication problems, and then add. 4 times $80.75 is $323, and 4 times $39.50 is $158, for a total cost of $481 for the family of 4. All right, let's look at one more of these, and then we've got an error analysis question at the end. Number 23, the boys basketball team is purchasing new uniforms. The cost is $8.25 for the top, $12.50 for the shorts, and $52.95 for the new sneakers. So I have in this box off to the right, which I probably should have covered up the answer, but it says, how is this problem different than the last two problems? What we notice here is that in the last two questions, we had two costs. It was the bus trip and the amusement park cost for the one problem. For the other one, it was the canoeing camping class and the food. Here we have three costs. We're looking at the top, the shorts, and the sneakers, probably at a discounted rate since we're looking at an entire team. So we're going to treat this really similarly. We can do as many costs as we want, but set it up in a similar way. So the two expressions I wrote, let me delete this box here. Maybe I'm going to delete it, or maybe I'm just going to move it out of the way since it doesn't want to delete. We've got 10 for the 10 team members that we're talking about. Oh, sorry, I should actually read part A. That would help. Part A says to write two equivalent expressions to find the total cost of the new uniforms for the 10 team members. So we had 15 students, we had 4 family members. In this one, we're looking at 10 team members. And the three things that they're purchasing are the $8.25 top, the $12.50 pair of shorts, and the $52.95 for the pair of sneakers. So that's going to go inside the parentheses, and they can go in any order we want. Now distribute, so we take 10 times $8.25. That will be the total cost for the entire team to get tops. 10 times $12.50 will be for the entire team to get shorts, and 10 times $52.95 would be for the entire team to get new sneakers. So now we go to find the total cost. You can see that I did that here. I took 10 times $8.25, 10 times $12.50, and 10 times $52.95. And that got us $82.5 or $82.50. That's for the top, $125 for the shorts, and $529.50 for the sneakers. And once you add those together, it should be a total of $737 for the entire team to get these items. All right, let's look at an error analysis question. I swear I can talk today. So for number 24, we've got Billy, Johnny, and Randy. They're simplifying expressions using the distributive property. We want to look at their work for the same problem down below and determine who is correct. And of course, we want to explain our reasoning as well. We want to be very in-depth. We don't want to just say Billy's right because his looks right, or Randy's right because his work looks right. We want to be very specific. So in looking at these three students' work, what I'm first noticing is that in Billy's work, he forgot to distribute the 4 to the 2, which is a huge problem, and it's a common mistake that students make. So Billy is not correct, and we'll explain why down below in just a moment. When I'm looking at Johnny's work, I see that he did distribute the 4 to the x and the 4 to the 2, and then he simplified. 4 times x is 4x, 4 times 2 is 8. When I look at Randy's work, I notice that he did the same thing as Johnny, but he went a step further, and he added 4x and 8 together. But we can't do that because we're not allowed to add things that are not like terms. So when Randy added 4x and 8 together, he's going to end up getting this question wrong because we cannot combine things that aren't like terms, which are things that have the same variable attached. Since 4x and 8 don't both have an x attached, I can't add them together. So what I explained in my reasoning is that Johnny is correct because he distributed correctly, but I went further. I said that Billy forgot to distribute the 4 to the 2, and Randy went too far and added 4x and 8, which cannot be added because they are not like terms. Again, it's not a huge paragraph, it's not a TDA essay, it's nothing super in-depth, but stating who is correct, stating why they're correct, and then looking at the other two and explaining why they're not correct is also important. Please keep in mind that the distributive property is such an important concept. It's one that you're going to use for the remainder of this year, and you're going to see in future years of math as well. So it's definitely an important one. And in terms of real life, I use the distributive property pretty often to calculate things mentally. So it is something that you might use in real life in the future. Thanks for listening.